You ever just step outside on a clear, quiet night and really look up? I mean, look past the streetlights and the trees, right up into the cold, silent void of space. Right there, anchoring the darkness, is the moon. It's so familiar, so constant, we're so used to it being there that we almost never stop to think about the absolute chaos it took to put it in our sky. In this explainer, we're going to peel back the layers of a cosmic event we take totally for granted. We have this tendency to assume our solar system has always been this perfectly ordered, peaceful clockwork of planets. But actually, the reality is so much more violent. The true story of our celestial neighborhood is a massive, cinematic saga of unimaginable heat and cosmic sculpting on a scale that honestly defies human comprehension. So today, we're taking a journey deep back in time to witness the majestic and frankly terrifying birth of our closest companion in the cosmos.
Tonight, the moon quietly hangs above Earth, lighting the darkness just as it has for countless generations. It feels permanent, as though it has always been there. But if you had looked into the sky 4.5 billion years ago, you would have seen something completely different. Earth had no moon. Just imagine that for a second. A totally moonless Earth. We're talking about the Hadean Aeon, named after Hades, the Greek god of the underworld, and yeah, that name is incredibly accurate. If you were standing on the surface of our newly formed world, you wouldn't be looking up at a peaceful, silvery sphere. You'd be staring out into a violently chaotic, hyperactive solar system. The skies would be completely toxic, choked with thick volcanic gases and lit up by the constant, merciless bombardment of massive, city-sized chunks of rock and ice careening through the void. The young Earth was just this hostile, molten world, covered in vast rivers of liquid fire, barely beginning the agonizingly slow process of cooling down. No gentle tides washing up on a sandy shore, just a solitary, desolate proto-Earth trying to survive in a ruthless cosmic shooting gallery.
Okay, let's dive into this. How was the moon actually born? For centuries, this question completely baffled the greatest minds in astronomy. Back in 1898, George Darwin, who was actually Charles Darwin's son, suggested the moon was just spun right off a rapidly rotating molten Earth, kind of like a drop of water flying off a spinning top. Others thought, well, maybe the moon was just a wandering asteroid that got snagged by Earth's gravity as it flew by. But as astrophysics advanced, the math behind those ideas just completely fell apart. The angular momentum was all wrong, the orbital mechanics didn't work out. It wasn't until this massive gathering of scientists in 1984 out in Kona, Hawaii, that a fringe concept officially became the accepted scientific truth. It's called the giant impact hypothesis. And to really wrap our heads around the sheer magnitude of this event, we have to wind the clock all the way back to the dawn of our world.
4.5 billion years ago. That number is just so staggeringly huge it almost loses its meaning, right? But to put it into planetary perspective, this was only about 20 to 100 million years after the solar system first started to form from a swirling disk of gas and dust. The planets were still desperately trying to clear their orbital paths of debris. At this point, Earth was only about 90% of its current size. It was this unstable, volcanic work in progress, orbiting a fierce, newly ignited sun. Gravity was basically playing a violent game of cosmic billiards with dozens of developing planets. It was a demolition derby on a planetary scale. And the thing is, Earth wasn't alone in its immediate neighborhood. Lurking dangerously close by, trapped in a delicate gravitational balancing act, was a completely different planetary body, a phantom world quietly growing in the dark, and it was on a direct, unavoidable collision course with our home.
So, let me introduce you to the second main character in our story, a Mars-sized protoplanet named Theia. In Greek mythology, the Titan Theia was the mother of Selene, the goddess of the moon, which is just a perfect name for the world that literally sacrificed itself to birth our lunar companion. Theia likely formed in what astrophysicists call a Lagrange point, specifically L4 or L5. Think of these points as gravitationally stable pockets, or like cosmic parking spaces, located right along Earth's orbital path. For millions of years, passing dust and debris naturally gathered there, and Theia quietly swelled to roughly the size of Mars. But that stability? It just couldn't last. Once Theia grew to about 10% of Earth's mass, its orbit became highly chaotic. The gravitational tugs from other massive planets, like Venus and Jupiter, began mercilessly pulling at it. Eventually, Theia drifted right out of its safe harbor, setting the stage for literally one of the most violent collisions in the entire history of the solar system. Now, computer simulations show us that this wasn't a direct, head-on collision. Instead, it was a devastating, glancing blow, striking the young Earth at roughly a 45-degree angle. Picture this. Theia is moving at an astronomical speed of roughly 9.3 kilometers per second. That is literally like crossing the entire island of Manhattan in one single second. At that terrifying velocity, when Theia slammed into Proto-Earth, the kinetic energy released was utterly incomprehensible. It was so energetic that it didn't just break the two planets apart, it instantaneously vaporized millions of tons of solid rock. The sheer friction and unimaginable pressure instantly created a global ocean of magma thousands of miles deep across our entire planet. Theia as its own distinct world was utterly annihilated. The impact turned both bodies into a swirling, blindingly hot mass of fluid and vaporized stone. It was a catastrophe of unprecedented proportions. But from this absolute destruction, something incredible was about to be forged.
When two massive planets smash together with that kind of ferocity, they don't just bounce off each other. They're forced to obey the strict laws of gravity and thermodynamics. Because of the extreme searing heat of the impact, Theia's dense metallic iron core melted completely and sank straight down through Earth's molten exterior. It plunged deep inside and permanently fused with our own core. Actually, this huge addition of heavy metal is a major reason why Earth is the densest planet in the solar system today. Meanwhile, most of Theia's outer mantle melted and just became a permanent part of Earth's mantle. We effectively swallowed the impactor whole. But the lighter outer crusts of both worlds? Stripped of their water and gases by the intense heat, they were blasted outward into space. And this material didn't just fall back down to Earth, and it didn't have enough energy to completely escape into deep space either. Instead, it was thrown out just fast enough to achieve orbit, forming a massive glowing, superheated ring of debris entirely encircling the wounded Earth.
So picture this newly wounded Earth glowing a furious, angry red with a churning ocean of magma, surrounded by a brilliant, incandescent ring of vaporized rock and dust. It would have looked like a magnificent, hellish version of Saturn, but on the cosmic timeline, this beautiful ring was actually incredibly short-lived. In the frictionless vacuum of space, gravity is a relentless, untiring sculptor. Over the next several decades, or maybe just a few centuries, which is an absolute blink of an eye in cosmic time, gravity went to work pulling this orbiting river of molten rock together. It started as this chaotic cosmic ballet. Tiny glowing particles bumped into each other, sticking together to form larger rocks, which collided in the dark to form massive boulders, which violently mashed together to form towering moonlets. Because this entire debris disk existed safely beyond the Roche limit, which is the specific distance where Earth's gravitational tides would just tear a large body apart, the material successfully coalesced. Countless glowing fragments gathered into a single, massive, cooling sphere. The Moon was born.
Now, today, we know the Moon is a distant 238,000 miles away. It's actually so far out that you could fit all the other planets in the solar system side by side in the empty space between us and the Moon. But right after it formed, the newborn Moon was terrifyingly close. Scientific models suggest it orbited roughly 14,000 miles above Earth's surface. If you could have stood on Earth back then, the Moon would have absolutely dominated the sky. It would have been an angry, glowing red orb, still radiating heat from its violent creation, just looming ominously right overhead. And Earth itself was spinning at a dizzying speed. The oblique impact of Theia had injected so much angular momentum into our planet that a single day on Earth lasted only about 5 hours. The early sun would just frantically rise and set, while this massive glowing moon raced across the sky in an incredibly tight orbit. But the young Earth and the newborn Moon were locked in this intense gravitational dance, and over the next few billion years, that unyielding connection fundamentally changed them both. Because the Moon was so incredibly massive and located so tightly to the planet, it exerted an immense gravitational pull on Earth. This gravity physically pulled Earth's solid crust and its emerging oceans upward, creating a massive tidal bulge. And since Earth was spinning much faster than the Moon was orbiting, Earth's rotation physically dragged this heavy bulge of water and rock slightly ahead of the Moon. The Moon's gravity then pulled back on that bulge. This acted as a massive planetary-scale brake, creating immense friction that slowly bled off Earth's rotational energy. As Earth's spin gradually slowed down, stretching our frantic 5-hour day into the steady 24 hours we have today, that lost energy had to go somewhere. It was transferred directly to the Moon, literally pushing our satellite farther and farther outward into deep space. And we are so lucky it did. As the Moon moved outward, its stabilizing gravitational anchor prevented wild climate swings and slowly established the gentle, rhythmic ocean tides we know today.
Now, what's really interesting about this slide is, how do we actually know any of this happened? This incredible story of fire, gravity, and cosmic rebirth sounds almost like science fiction.
And for decades, the giant impact hypothesis was exactly that, just a brilliant, mathematically sound idea on paper. We can't exactly build a time machine to watch the Hadean eon unfold. The definitive turning point didn't come from some massive telescope peering deep into the cosmos. It came from the brave hands of human beings bringing actual pieces of space back home. The historic Apollo program in the late 60s and early 70s brought back hundreds of pounds of pristine lunar rock and alien soil. When geochemists finally started cutting into these ancient rocks and deeply analyzing their chemical makeup, they uncovered the unmistakable, physical fingerprints of a planetary crime scene. This is where the true magic of planetary science comes in. You see, every single planetary body in our solar system has a highly unique chemical signature, especially when it comes to stable oxygen isotopes. Think of these isotopes as a sort of planetary DNA test. Mars rocks have a distinct DNA that looks totally different from Earth rocks, which look entirely different from asteroid meteorites. But when scientists tested the Apollo moon rocks, the results were absolutely staggering. Their oxygen isotope ratios were practically identical to Earth's, virtually indistinguishable. This was the smoking gun. It meant that Earth and the moon absolutely had to share the exact same parentage. They formed from the same source material. Yet there was one glaring difference. The moon rocks were severely depleted in volatile substances, stuff like zinc and potassium that easily boils away at exceptionally high temperatures. Plus, seismology showed the moon has an abnormally small iron core compared to Earth. Well, the giant impact hypothesis elegantly answers every single piece of this puzzle. The terrifying impact was hot enough to vaporize those volatiles, meaning the moon lost its zinc to the void of space. The early Earth absorbed the heavy iron core of the impactor, leaving the moon iron poor. But because the bulk of the moon was made from the vaporized outer crust of our proto-Earth, their oxygen isotopes, their planetary DNA, match perfectly. Our closest celestial companion wasn't peacefully born. It was forged in one of the most violent collisions in the history of the solar system. When you step outside tonight and look up at the moon, bathed in that quiet, silvery light, I really want you to remember that profound truth. It isn't just some passive, lifeless rock floating aimlessly in the dark. It is the scarred, silent survivor of a planetary apocalypse. It's quite literally a displaced piece of our own early world, violently mixed with the superheated ashes of a destroyed ghost planet. Sculpted by the relentless, untiring hands of gravity into a brilliant beacon, it has stabilized our climate, dictated the rhythm of our oceans, and illuminated our darkest nights since the very beginning of our world's long history.
While Earth and its newborn moon finally settled into a stable, enduring orbit around each other, slowly drifting into a peaceful rhythm after an eternity of chaos, the broader universe around them was far from quiet. Across the unfathomable expanse of the galaxy, deep within vast, swirling, luminescent nebulas, countless other massive clouds of gas and dust were beginning an even greater, more explosive story. Gravity was hard at work on a much grander, more terrifying scale, relentlessly compressing ancient matter tighter and tighter until it sparked the awe-inspiring nuclear fires that light up the cosmos. Our solar system is just one tiny chapter in a much larger, ongoing cinematic epic of creation and destruction. We are leaving our planetary neighborhood behind to journey out into the deep universe. Join us next time as we explore exactly how stars are born.